All right, so we are going to do the exam one review, and I've got a couple of questions here. There's about 17 of them we're going to go over. These will be similar to what you have on your review, so we'll just kind of talk about them. First of all, you got to know the vocabulary words. The very first lesson I told you, you need to know the vocabulary words. And you need to know it from Chapter 1 and Chapter 2. They're on your handout, so they're listed. A lot of them are listed like right there together. And then some are going to be maybe, in the middle of the lesson, so you'll have to pay attention. I know at some points there was some that we did a part of the lesson, we did part of this lesson, and then there's some more down here. So you've got to know these words. There will be some multiple choice, some fill in the blank, some short answer on those. There's some true and false, but you got to know the definitions or you won't be able to just, guess your way through. You can try, but those should be questions that you know these words. And the other thing is, if you don't know what the words are, you're going to struggle the rest of the semester. You've got to know what those words are because we're going to keep you using them. So learn them now, because otherwise you're going to learn them later, and you want to get those points on the test. If there's math that we did this section, you'll be doing that math. There's not a lot of math in this, but if there's math, you're going to need to show that. Also, on the test, you'll want to make sure if you're adding, subtracting, multiplying, or dividing, you write that work down on the exam. One, because it's part of the credit that you can earn, and two, if you make a mistake, I can give more partial credit if you actually have written it all down. So we're going to go through these questions, and if you have any questions after the fact, then let me know. We can either meet or you can ask me questions either through email or remind. All right. So, know those vocabulary words. Can't stress it enough. And the concepts like around those words, like we talked about in the first couple of lessons. All right, so our first question is, does it make sense? Why or why not? So, let me be clear. The questions will be similar to these, but not exactly these. So, you're going to have to know the concept of it. The ones on your review are slightly different. So, it'll give you some different concepts to look at. But they won't be this exact question. It'll just be similar. All right, so the price of a gallon of gas tripled, so that means it increased by 300%. All right. Exam 1 review. And we're looking at exam number 2. So it does not make sense. You might recall this one from the lesson. We talked about that if the price tripled and we had a $1 price, if we multiply that by 3, we would get a $3 price, right? If it tripled. Now the increase in this is 3 minus 1 gets you 2. And 2 compared to the 1 is a 200%, not a 300%, right? So we talked about that before. So make sure that you are giving me some reasons. So it doesn't make sense, it does make sense, and then give me your best guess reason. Don't leave things blank as well. A blank question gives you 0 points, but you might actually do the right answer if you try it. All right, number 3. In each study, identify the sample, the population, the sample method, and then indicate whether the sample is likely to be representative of the population. So we got to know several things here. So in a Gallup poll of 1059 randomly selected adults, 39% answered yes when asked, do you have a gun in your home? All right, so let's look at our sample. So first of all, we're selecting adults. We selected 1,059 adults. So that's going to be our sample. We'll also have our population. We'll have our sampling method. All right, so the sample is 1,059 selected adults. So if that's the sample, our population is going to be the complete set of adults. Okay. Now the sampling method, what did it say happened here? So in a Gallup poll, they were randomly selected. There's no other clues that it was anything but that. So we are going to state that it's just simple random. And then indicate whether the sample is likely to be representative of the population. Well, they polled 1,059. It's also by Gallup. Gallup is a name of a poll. It's a well-known name. But the fact that they gave us a name on the poll, we have 1,000 people. That's not a bad thing. 39% answered yes when they asked if they had a good. So with that Gallup and that 1,059, it's probably going to be that way. So representative will be the question. Representative. We're going to say it's the sample is fairly large. And let's see, the survey, is it a survey? Or the poll. The poll was done by a reputable firm, which is Gallup. And so we're going to say yes. So because of those two reasons, yes, it is likely representative of the population. Okay? So I've given a couple of reasons why I think it's representative. All right, number 4, we are going to identify the confidence interval. So we're going to use the given statistics and the margin of error to identify the range of values likely to contain the true value of the population parameter. So USA Today reported that among 6,028 adults observed in restrooms, 85% washed their hands. The margin of error is 1 percentage point. All right, so we want to find the confidence interval. So if you recall, we have to take our statistic, the 84% that wash their hands. We're going to take the 84. Is it 84? Nope, 85, sorry. The 85% that wash their hands. We're going to subtract that margin of error and get 84. And we're also going to take 85 and add 1 and get 86. So our confidence interval is from 84% to 86%. That will be our confidence interval. All right, number 5. A study of 3,005 adults aged from 57 to 85 showed that 82% of them use at least one prescription drug. The margin of error is 2 percentage points, and it's done by this whole study. All right. Based on the given information, state what you think was the goal of the study and identify a possible population and population parameter of interest. Well, it looked like they were trying to determine if the adults aged 57 to 85 used at least one prescription drug. All right, so here's our goal. They want to determine the percentage of older adults, and I'm going to put aged 57 to 85 years because that's specifically what they said in the study, who use at least one prescription drug. So that is our goal. So if that's our goal, what is our population? Well, the population is going to be that complete set of older adults, right? Because that's what our part is older adults. So the population will be the complete set of older adults. Now, the other part we have is the population parameter. So what are we trying to figure out with regard to those older adults? We're trying to find out the percentage of all older adults who use at least one prescription drug. So this is similar to our goal, right? We're kind of pulling parts of it out. So the percentage of all older adults who use at least one prescription drug. Okay, so the population parameter is a little bit similar to the goal. The goal is saying that we're trying to determine it. We've got our population as the complete set of older adults, and you need that word older because it's not all adults, it's the older ones. And then the parameter comes inside that goal. Hey, this is specifically what we're trying to find. All right. Now, part B says to briefly discuss the sample, the raw data, and the sample statistics for this study. All right. So we're now looking at part B. In part B, we want to find the sample. Well, the sample was how many people were studied or that were selected, right? And it said that there were 3,005 older adults that were selected for the survey. Okay, so that came straight off the very first statement that 3,005 adults aged 57 to 85 showed. So that's the sample right there. Now, the raw data, because we are asked to find that, and these are some of your vocabulary words as well, right? The raw data is the data that hasn't been processed, and in this case, it's going to be the individual responses to the question. So each of these that answers the questions, it'll be their responses. And then our sample statistic is the value. It said that the study showed of those older adults that 82% of them used at least one prescription drug. So the statistic is the value, the 82%. Okay. All right, and then part C says to, based on the sample statistic and the margin of error, identify the range of values, confidence interval, and likely to contain the population parameter of interest. So this will be part C. So we know that we have an 82. That is our sample statistic. We've got to look at our margin of error and figure out the confidence interval. We were told that the margin of error, right here, is 2 percentage points. So that means to find our confidence interval, we're going to take our 82 minus 2 equals 80, and our 82 plus 2 equals 84. So our confidence interval is going to be from 80% to 84%. Okay? Now we've already done 2 problems with that, right? We already did that on number 4. We're doing on number 5, so you're going to need to know how to do that, I would say. All right, number 6. So for number 6, we want to determine whether a census is practical in the situations described, and explain your reasoning. You want to determine the mean weight of all high school football players in the state of California. Well, a census isn't going to be practical for this. First of all, it's a very large, if you think about the state of California, it's really big, right? It's big, just like Texas, which is where we're at. So all the high school football players, that is a lot of football players, right? Because we're not talking like a county, we're talking the whole state. So it's a really large number, and probably too large to be doing a census. And yes, I know we take a census of the whole population of the United States every 10 years, but to do all of this is going to be a little bit different. The other problem with a census is that you're not going to have that data readily available. Because first of all, they're high school students, right? So that data may not be as easily available, like to find it online or whatever. So you might want to do something else and figure out a different way to get that information. So we're going to say that a census isn't, let's rewrite that, is not practical. The number is quite large, and the information is not readily available. So they might need to look at another type of way to find out that information, or maybe they need to change what they're trying to locate. All right, number 7. So on number 7, determine whether there is a potential for bias and explain your answer. Consumer Reports magazine prints a review of new cars and does not accept free products or run any advertisements from any of those companies. So they're reviewing new cars, but they don't accept free products. So free products will get you to be a little on the bias side. So no free products, and they also don't run any advertisements. So by not running advertisements, they are not being biased because they are like it's still got money involved. If they're running advertisements, they don't want to lose that sponsorship, right? So because they don't do any ads and they don't take any products, then this is not going to be biased. So no bias. Our reason would be the magazine does not accept free products or run advertisements. So that means it's not being influenced, okay? It's not being influenced by the makers of the cars. So that's why they're not being biased. All right, number 8. Identify which of the following applies. Is it a simple random, systematic, convenience, stratified, or cluster? State whether you think the procedure is likely to yield a representative sample or a biased sample and explain why. On days of presidential elections, the news media organize an exit poll in which specific polling stations are randomly selected and all voters are surveyed as they leave the premises. All right, so let's recall what that looks like, because we've got to know what these things mean. So if you remember these guys, if we are just randomly selecting, we're just randomly grabbing one here or there. Everybody has a chance to be asked, but we're just randomly grabbing. If it's systematic, we start with someone, and then like here we're doing the every third, every third, every third, right? Starting with this group, we've got every third, every third, every third. Now, stratified, remember we create the stratas or the groups. So these are the all purple, all blue, and so forth. And then we randomly grab the same number out of each group. But cluster, we separate them in the stratas or groups, and then we grab the entire group. Okay? So if we're talking groups, we're usually talking strata. We're out of the groups, we grab a couple, or we grab the whole thing. Otherwise, we've got a simple and a systematic. So let's read our question on number 8. So on days of presidential elections, the news media organize an exit poll in which specific polling stations are randomly selected and all voters are surveyed as they leave the premises. So they're looking at the polling stations, so they're looking at grouping the samples in specific polling stations. So they're organizing them. They go, okay, we've got this polling station, this polling station, this polling station. And then what they're doing is they are, all the voters are surveyed, right? So that means we're making groups and we're collecting from all of them. So not a few, but all of them. So that means this is a cluster sample because they're selecting all of the voters that leave. So cluster sample. And it also asked, state whether you think the procedure is likely to yield a representative sample or a biased one. So it's likely representative. First of all, it's happening on election day. Remember, we had that question where it had been like 2 months since they had, or 2 months before the election, where we said, well, they might have changed their mind during that time. So this one's probably more like a representative. But the thing we don't know is how were the polling stations selected. So we don't know the exact method of selecting the polling stations. Now, why do I mention that? Well, it depends on how they chose the polling stations, because that could make them biased. So if they specifically chose neighborhoods that were all Democratic or all Republican or more so one way or the other, instead of getting some that are Democratic and some that are Republican and or independent or whatever. If they don't choose the sample well, the stations where those are representative, then it could be biased to one or the other. All right, let's go on to number 9. So number 9, we're determining whether the study is an observational study or an experiment or a meta-analysis. We got to explain our choice. So in a Harris Interactive Survey of 1,006 randomly selected subjects, 96% of adults said they wash their hands in public restrooms. All right, so what is this one? Well, this is not an experiment because there was no treatment happening, right? It also wasn't a meta-analysis because we didn't look at a major amount of studies from the past. Instead, we're observing what they're doing. They wash their hands, we're just asking them, and it's just an observation. So this one will be observational for part A, and the subjects were surveyed. And not given any treatment. Okay? There also wasn't like a lot of data from somewhere else that happened. All right, part B. So for part B, tempered glass is used for car windows because it is much tougher than regular glass. A researcher tests the strength of samples of glass by heating them at 620 degrees Celsius, which is the industry standard. So is this one observational? Is it experimental, or is it a meta-analysis? Well, they're actually doing something to the glass. They're doing a treatment. So this is going to be experimental, or an experiment, because they're treating the glass. Or we could do this. Samples of glass are treated. Okay? And then part C. Part C says that hundreds of separate and individual scientific and statistical studies have been done to determine whether high voltage overhead power lines increase the incidence of cancer among those living nearby. A summary study based on many previous studies concluded that there is no significant link between power lines and cancer. So they're not doing a new study. Here they're looking at hundreds of separate and individual scientific and statistical studies. So that is where they're doing a meta-analysis. It's kind of like, reminds me of like mega, but it's a meta-analysis. And I remember when I was younger where they used to talk about this a lot, like, oh, if you live near those power lines, you're going to get cancer. But they have studied and studied and studied and studied and have figured out that that's not the case. All right, so it's a meta-analysis. And all of the individual studies are observational, because they didn't, even in all of the studies, they weren't doing experiments. They were taking notes, like, did the people that lived there get cancer or not? And so those would be observational studies where they observed what happened. They didn't actually do anything to the people. All right, we're on to number 10 already. So for number 10, for each of the studies described, identify any problems that are likely to cause confounding and explain how the problems could be avoided, and discuss any other problems that might affect the results, such as a placebo effect. So we have a professional driver is used to compare the handling of Ford Taurus cars and Porsche or Porsche 911 cars. All right, so is confounding possible here? So let's talk about this again. A professional driver, not somebody who doesn't know cars at all, but a professional driver who knows what cars are and drives them professionally, is used to compare the handling of the Ford Taurus and the Porsche 911 or 911 cars, right? So, do you think the professional driver is going to know the difference between the Ford and the Porsche? Well, probably so. He's going to recognize what a Porsche looks like, I'm sure, and versus a Ford Taurus. He's going to be able to tell the difference. So this one is going to have confounding in it. Confounding is very possible. And because it is not possible to disguise the car models. You can't just wrap them in a box and then not be able to see what they are. He's going to know. They have different reputations, they're very different prices, and those could affect the evaluation made by the driver. So, the cars have different reputations and different prices, because he may know, hey, this is a more expensive car. It's got to be better, right? So that's where you're going to have that influence. And those could affect the evaluations made by the driver. Alrighty? All right, number 11. I didn't finish that. Let me add just a little bit. These could influence the driver's evaluations. Just to make that clear. All right, number 11. So for 11, we're going to determine which of the 8 guidelines appears to be most relevant and explain your reasoning. So we talked about the 8 guidelines when in the lesson, and we talked about you would need to know the 8 guidelines. So just like you're learning the vocabulary words, you need to know what the guidelines are. You don't have to memorize them word for word, but you do need to know what the guidelines are, and you need to know the basic concept of them. So here are the 8 guidelines. Remember, we have to get a big picture view. What's the goal of the population? Consider the source. Look for bias in the sample. Look for problems defining or measuring a variable. Be aware of confounding variables. Consider the setting and wording in the surveys. Check that results are presented fairly, and stand back and consider the conclusions. So let's look at our problems here. Our first problem says a clinical trial of a treatment intended to help smokers stop smoking was conducted. The sample consisted of male college students, and the trial showed that for American adults, the treatment is effective. All right, so which of our guidelines is going to be an issue here? A clinical trial of a treatment intended to help smokers stop smoking was conducted. The sample consisted of male college students, and the trial showed that for American adults, the treatment is effective. All right. So, get a big picture view. Probably not so much. Consider the source. No. Look for bias in the sample. So, if we recall, let's remind ourselves what the word bias means. Let's pull that up. The bias is if the design or implementation of the study tends to favor certain outcomes or results. Look for problems defining or measuring a variable. Beware of the confounding variables. Consider the setting and wording in the survey. Check that the results are presented fairly and stand back and consider the conclusions. Well, if we look at this, it's a sample of male college students, right? So the effectiveness of the treatment does not necessarily apply to the whole public. Also, it's college. It doesn't have a wide variety of age groups. So I know there's some that are non-traditional students, but typically in a college, you're going to have the younger crowd, right? So we have to become aware of that. So it's not representative of the whole thing. So it's going to be a biased sample. So this is going to be guideline 3 because it doesn't represent the whole thing. It doesn't apply to the general population. It does not apply to the general population of American adults. Okay? Because it does not represent everybody. All right, so this was A. Let's go look at B. All right, so an independent research firm conducts a survey of adults who view movies. Each interview subject is asked this question: Is there too much violence in movies? All right. Well, what is that? Well, how much is too much violence? It's going to change from every person, right? I am going to not like any violence in the movies, and other people are okay with quite a bit of it. So that's a subjective answer or question, and it's open for different interpretations of how much violence is too much. So the question does not address a variable that can be measured in a meaningful way. So it is going to be look for problems defining or measuring a variable. So it's going to be guideline 4. Okay? So we're going to say the question is vague, hard to define, too much violence. So we're going to say it's guideline 4. Now, do you have to tell me it's guideline 4? You should try to know those, but even if you don't know 4, you need to know the title of the guideline. Don't go like, well, you got to tell me. It's the guideline that looks for problems defining or measuring a variable. Okay? So, but it'd be good if you know which one it is, because then it's easier for you to, continue to move forward in knowledge. All right. Part C says a survey included this question: Do you favor or oppose raising taxes to be used for wasteful spending on science research projects? All right, so here's our clue. The use of wasteful, they're already like giving you some stuff like, hey, this is bad, this is wasteful. So they're trying to encourage negative responses with that wording. So the wording is not appropriate. And so we're looking for guideline 6, consider the setting and wording in surveys. All right. So, use of the word wasteful is likely to encourage negative responses. Okay? So, wording is not appropriate. And so you're looking for guideline 6. Now, any formulas will be available on your exam, but the guidelines will not be listed there. Those are not a formula. That's something you need, that's a concept you need to know and understand, okay? But any of the formulas that we use would be there. Not that there's a lot of formulas here, but if we do, they'll be there. All right, number 12, identifications. Let's see. For determine whether the data described are qualitative or quantitative and explain why. The television shows being watched by households surveyed by Nielsen Media Research. So we're talking about the television shows that are being watched. Well, television shows, those are a name, right? So those are going to be qualitative. So TV shows are a name, right? Are names. So it's going to be a qualitative. You can't put that in any kind of order or a ratio or anything like that. It's just, I mean, yes, you could alphabetize it, but that wouldn't mean anything significant other than it's alphabetized. All right, so that's qualitative. Part B says the number of households with a television in use when surveyed by television or Nielsen Media Research, sorry. So the number of households with a television, well, that's a number and we can count that. So this is going to be the number of households will be a quantitative because we can count them. All right. Number 13. So for 13, state whether the data described are discrete, continuous, and explain why. The times, years, it takes college students to earn a bachelor's degree, such as 4 years, 4.5 years, 5 years, and so on. Well, we're looking at, it can only be certain values. It's 4, 4.5, 5, 5.5 years. So it can only be those certain values and no values in between. So this is going to be discrete. It can only be certain values. It can't be any value. Now, the exact times required by students to reach their first class, oh, that can be any kind of time, right? This is continuous because the times can be any value. You know, it can be like 4 minutes and 32 seconds. It could be, it can be any value at all. All right, number 14. We're going to identify the level of measurement. Is it nominal, ordinal, interval, or ratio? All right, so the number of words spoken in a day by a sample of males. Is that going to be nominal, ordinal, interval, or ratio? Well, we can actually take the number of words spoken by a sample of males, and we could even say that this guy spoke this comparatively to another one. We could ratio those. It does make sense. We can make a ratio out of those values, so it could be a ratio. All right, the scores of 0%, 1%, 2%, all the way up to 100% used to rate the quality of a movie. Well, they're in an order, and the order matters but we wouldn't do like a ratio of those. And we're not going to do an interval. It's a qualitative one because we're rating the quality of a movie, right? But it does have numbers that actually go in an order. So this one would be ordinal. All right. The types of movies: drama, a comedy, could be horror. Those are a title or a category. So that's going to be like a name. It's nominal. We're not going to do any kind of numbers with those. All right, we are on number 15. So for number 15, it says find the values of absolute and relative errors. Here's some math. You're going to want to show all your math. So the official distance for a marathon is 26 miles, 385 yards, or this value here. But the organizers of a marathon map a course that's actually this distance, which is miles in length. So we have two values here. Remember that your absolute error is going to be, I want to make sure I use the words that make sense. So the absolute error is going to be the measured value minus your true value. So the measured value will come first. And in this case, we have a measured value. We're going to subtract the true value. So the absolute error will be equal to the measured value minus the true value. So in our case, the measured value is what the city did. And then we're going to subtract out the true value of what a marathon actually is. And we end up with 0.12692 miles. So not that far off, but it's still not the exact value. Now we need to find the relative error. And if you recall, the relative error is going to be the absolute error divided by the true value and then times 100%. All right, so in this case, our absolute error, we already know that, 0.12692 over our true value, which is 26.21875, and we'll need to multiply that by 100%. And when we do that, we're going to get 0.5%. So we're not going to put the percent sign in the calculator. We will take this, divide it by that, and multiply it by 100. Okay? All right. So that was number 15. We have 2 left. All right. Number 16. Express the following numbers in the 3 forms of fraction, decimal, and percentage. So on 16, we have the number 3.75. Well, it is already, this is a decimal, right? So we have the decimal part. We need to do a fraction, and we need to do a percentage. Well, if this is 3.75, we can put this over, like out of 100. So we can make this into a fraction. So if I'm going to put it over 100, though, I've got to move my decimal place. So it'll be 375 over 100. And I'm going to want to reduce that down to 15 over 4. Okay? They both divide. You can see that they're both going to divide by 5s. You could even see maybe they divide by 25s, but you keep reducing it down until you get it to a reduced fraction as much as you can. If you don't reduce it, I'll only take off a point. And then we've got to change it to a percentage. So the percentage is basically what we've done here. To change this to a percent, I've got to move it over 2 places, so 375%. And maybe you can see the percentage and see that that's out of 100, and maybe that makes it easier to do a percentage and then get it to a decimal. You may start with something that's a fraction, and then changing the fraction, like 15/4, changing that to a decimal or a percentage. So just be aware. Know how to move those numbers around. All right, last question. Are you happy about that? All right, number 17. For each pair of values, use a percentage to express their relative change or difference. Use the second given value as your reference value and express results to the nearest percentage point. Also write a statement describing the result. All right, there were this many bankruptcy cases filed last year, and in the year 2000, there were this many bankruptcy cases filed. So even if it doesn't tell you to use the second value as the reference value, you should understand that if we're talking last year, that's going to be more recent than in 2000. So 2000 is going to be your reference value because it's the older value, right? So that's what we're referencing from. And so you need to understand, even if it doesn't say that, what that means. So we're looking for the relative change. So if we recall the relative change, let me move my papers here. So the relative change is going to be equal to the absolute change over the reference value. And again, we're going to multiply that by 100%. Now, if you don't know what the absolute change is, it's very similar to what we just did in problem 15. It's going to be our new value minus the reference value over the reference value, and then multiplied by 100%. All right, so our new value is the one that happened last year. So that'll be the 1,038,280 minus our reference value of 1,276,900 all over our 1,276,900. All right, I'm going to work this a little bit before I just jump to the answer. I want to show this part on the top. So that'll get us negative 238,620 over 1,276,900. You want to do this because otherwise if you don't put it in the calculator correctly with parentheses, you're going to mess it up, and I want to see this anyway. I want to know what you understand, not what the calculator does. Oh, and we're still multiplying by 100%. Now at this point, you could put this in the calculator, and it's going to get you like negative 18.687%, and you can change that to negative 19%, okay? Now, what does that mean? Because it said to explain what that means. What that means is that there, because it's a negative value, we had a 19% decrease in bankruptcies from the year 2000. So the bankruptcies went down. All right, so study, 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 work out your review. Please understand that your review has a bonus value on it. You need to, it's worth a daily quiz grade, and it's up to 5 bonus points on the exam. This is the only extra credit you can earn in the course, and test points count the most, so you want to work this out on separate paper and then submit it into D2L. There is a key, but don't word by word it. Do your own thing. in order to put it into D2L as a single PDF document, not multiple JPEGs, because you've got to do one single PDF document. You can use any kind of you can use like an Adobe thing or Cam Scanner or any type of scanner app, or use a printer that has a scanner ability to make it into a single document. Make sure you study, and good luck.